Okay, we're on 0 volts. I'm going to have to put the power down, but the interesting part, of course, is when we get to see what's going on, is as I just start increasing, we're actually on 1.2 volts, 3.7, and we're going up, and that's on 1 amp, so that's like 500 milliamps, and that is at that voltage. That's too much. Yeah, I don't, if it's in 100 milliamp range and I see it just like ping across to like 90 milliamps and drop back down again, that's normal, that happens on this. But to be going up past that 500 milliamps while I'm doing that, that means I got some breakages. Now let's just unplug that, and I'm going to show you by just turning this here, because this is when I realised, oh, I should have been videoing this. If I get that like that so you can see. So this one, I could just disconnect everything here, because we just know then that's all pretty much isolated. I'll leave this one on just for the minute. It's ground. So I'll take this off. Take that off, put it out of the way. And this is what I noticed, right? That was when I went to take this one off. Of course, I couldn't actually get this to release because it's stuck to the package. So I think that got a little tad warm. I actually want this back without doing too much damage to my actual to this, but I think it may be quite firmly. There we go. So, okay, look, it's not really, again, I soldered them from the backs to the front, so that little blob there is just, it's just the way it is. As long as we got a connection, all I want to do, this isn't the final solder part of these, I just want to see if we've still got a short. We're on 0 volts over there. I'll put this down, and it's the current that we're going to be looking at. Well, I've got 2.4 volts at the minute. We've got very slight going up. So I'm just going to take that power off. We're not shorting out. That's nice, but we are going down. It normally hangs around about 4 volts. So that is a thing. So let me just switch that on to milliamps, because I want to be able to see a little bit closer. But that is going down. Like I say, it normally would sit about 4 volts on those capacitors. Maybe it's not, because we only went up to about 4 volts. Okay, let's think about it like that. Let's not think it's a complete disaster. So this is milliamps now, on 100 milliamp range. I'm on 5 volts. I expect it to go up a bit. On 7 volts, I don't expect to see it rising too much further than that. And that's both on both sides. Maybe that's indicating that there's another issue. Right, so the first thing I was just going to do is just make sure that these connections are actually connected. And I've taken off these, the wires, just to make sure, because this is the ground output, this is the positive signal output from between these two. So now I'm going to check capacitors, because they would soak up current if there's a problem there, and just start working backwards. See if this is any sort of benefit to me now. Checking the circuit. So first of all, I'm going to zero these things, just because it likes the idea of that, even though before when I've zeroed, it's not actually showing any difference before on the what it actually shows me. Now I don't see why the 50 volt one should go, but I'm going to test it anyway, because of the whole idea about testing in the circuit. And that's why I got this for, was to be able to test in the circuit. I'm much happier to do a lot more troubleshooting on the circuit that I've actually built. Okay, so that's overflow if that's reading that capacitor. So, okay, let me see if I can just get a little bit better on that, because it's, make sure I'm definitely on those two where I'm supposed to be. Okay, now it's good cap if below 200 microfarad, and it is 100 microfarad. So let's not think that that's the problem so much. Now there's this other capacitor here. I should be able to get to that actually from the top. I just need to bring my light down. I'm not sure how much that's going to affect this screen. Let me just get a connection on this lead here if I can. I may not be able to, I may have to just press it on there. Press on this one, and you can see what it says on there. Good cap if below 470. Okay, that's good. Now this is only for electrolytics. Let me test the bootstrap just because it's here and I can get to it. Good cap if below 470. That's another 100 microfarads. So that's good. Let's try this 100 microfarad just here. Oh, I'm just going to eliminate what I can from this, and I don't expect it to be the input capacitor at all. So let me just check this here. Again, good cap if below 200, and it is. It's 100 microfarads again. So those seem to be okay. Now I'm pretty sure then, if those caps are okay, that these film 100 volt jobbies will be okay. We're going to be looking at the driver transistors, I suppose, but I'm just going to check the resistance on this 10 ohm here and just make sure that that's still 10 ohms. Okay, so I'll stick it onto the 200 ohm range, and I'm just going to look at the resistance between these, actually, these two. I've got the hook clip things here. What we got? 0.2. Okay, so we can take that into account in the measurement. So let's just have a little look at this. Now, I could probably get on this from here and get on it from there. We should have sort of 10. Yeah, that's good. Taking into account we had like 0.2 anyway. So I got a funny feeling it's going to be these transistors. So I'm going to get that solder iron back out again and take those out, because I can't just clip those the way they are. Well, I've managed to get this part from the off the circuit. I've not taken it out because I've not tested it yet, but I'm just going to do a quick little test. I don't care which lead goes on which here, because we just want to know whether this thing is a worker or not. And in a way I don't want it to be, and it's not. Okay, so we managed to kill off that transistor as well, and this one, even though it was a pain in the arse, I'll show you that I managed to get a reading off this. So I just connect onto that, don't want to touch the other one, connect onto this, and come here, connect onto that, and the difficult part here is going to be, it's just if I stick that there, just like that. Now, just so you can see, it was easy when I was just doing it for me, because I've got to be able to see the bloody thing, see, so now I'm going to just get that so it goes on to this, because it just catches. It's not, the collector's the middle one, otherwise I could put it onto the back plate, you know. If I do that, it's sticking into my finger, but it's still holding it there. Again, it's no good. So both of those driver transistors are blown then. That one might be a little bit dubious the way I'm actually trying to read it, but the other one is definitely blown. So I'll take that out of the circuit and replace those. Okay, so we've got two transistors in, got 2 new drivers in, and let's just give that a little bit of a check and see what happens. Okay, well that's a nice sign. But it's not shorting out to 0. I don't know if you can see that on one. It's not shorting down to 0, which it was, which means I've got a little bit of juice in those capacitors, and it's coming out. I'm not just look, just sit like that nicely, like I want you to. Okay, let's just put some power on. So we're on 0 volts on the AC. I'm gonna put this down. I'm gonna have you in my hand because you're gonna look at the look. There we go. That's not what 1 volt was going on about. Because we're gonna look at the current. We're on 100 milliamps still. Of course, nothing's changed. All I've done is just made these changes. Oh, that's a bit wibbly wobbly on there, but never mind. Let's see. Oh, I just knocked the thing underneath. Just frightened myself. Right, so let's start going up. Okay, we're on 2.3 volts. That's quite nice. 7 point something volts. On 12 volts. 12 volts. Oh, we've got LED on. 30 volts. I'm just gonna turn that down a little bit because it's not actually going up the way I'd expect it to. I'd expect it to go up a little bit more. I'm just a bit petrified of what I'm doing. But another reason for me to just turn it down is so I can just turn that juice off, and I just want to see if that reduces. I can't tell if it's going quicker. Maybe that's just because that's just the LED just sapping that little bit out. Because the LED, look, you can see is on. Just going to do a little heat. Nothing. Just, I don't expect anything across these anyway. But there's nothing. I've got nothing going into the input, so it shouldn't have anything. I'm just putting that in there to keep it out of the way. Shouldn't really have anything needing to go through the transistors. So let's just start taking it up a little bit more. Okay, right. Oh, put the power down. Probably a good idea. And let's start going up. So we're on 12, 14, 15 volts. 30 volts. I want us up to 50. And we're hardly using any juice, so really at 50 volts there, where's my little biasing twiddly tool? I'm just going to see if we can adjust that bias. Not really got anything going on there, so I'm just going to off that power down. Do another temperature check. Nothing, but that wasn't really making any sort of adjustment to my to the current being drawn. So I need to go over those connections again. There's nothing horribly wrong, but there's something not quite right. So I'm going to take another check, have a little look at that. And just to say, like, it's not rushing down like there's a short at all. And of course that's I think I might have found something. I just need to check, and there's the connection here, which would be from this transistor. There doesn't look like it's making a connection correctly, so I'm just going to do a quick continuity there, see if I get anything. And if that's the case, give that a bit of a bridge. Actually, in fact, I might as well just show you me doing this moment, so we both get to find out together. Let's put this in for a bit of continuity. Okay, and let me just zoom in. So I can go from anywhere here to anywhere here, and I should get a beep beep, and I don't. I'm putting that together myself. But if I'm to connect there to here, where I should get a connection, I haven't, and I can see that should be there. And I've made that connection there, and I'm going to power it up. Okay, we've got 8.2 volts, and it's not drifting down, which is okay. It's not actually going down at all. If I put my fingers on there, that shouldn't make any difference really. So, okay, let's give it some voltage and let's take a peek at that 100 milliamps. Now I've adjusted the bias, which is going to need setting back up again, and I need to unplug this phone. So I didn't know how much I was going to pull that around by unplugging it. So right, so we've still got 8.3 volts, which is good because that means we're not actually sapping any life out of this. I'm just going to turn that down so we can go gradually. Okay, power's on, and let's have a look at that current, as that's going to be the most interesting thing. I don't actually have anything going on at all, so something's not correct. Something is not plugged in or doing what it's supposed to be. Let's just make sure that's in there. Probably not the greatest of fits. Okay, that's better. That's how I expect to see it going down. That's how it normally goes down. Oh, this is good. I do like the idea of this. So let's start taking that up then. We got current going up. Well, okay, that's going to do a little buzz up, and it's flipping right over. That shouldn't be doing that at all. That shouldn't be doing that at all. That could just be the bias in there. So let's just get the twiddler and turn that down, because I did play with that. I'm just going to give that a bit of a turn all the way down and just see if that makes any difference to that current draw. And let's see what happens. So I'm on 3, 4, 5 volts going up, and that's still doing it. Nope, we got an issue. We have an issue, Houston, so I need to go back and look at it again. There you go, so this, the VC546, which sits in between the 1K and the 2K pot, and also collects from collector to collector on the 140, and emitter to the other side of the 2K pot. If we do a little test here, you get to see it's had its ass kicked. So it seems like I blew the two main output transistors, I blew the two driver transistors, and I blew the biasing transistor. I've already checked the other ones and they're okay. That is actually disconnected from the circuit in case somebody thinks I'm trying to do this in circuit. And I disconnected the other ones from the circuit as well. There's more beer. Okay, let's stick that down there. Oh, that's nice and cold, beautiful. Get this thing powered up. So that's 5 transistors changed. I should try not to blow it up again, but chances are I will do, because that's the sort of thing I do. It's not power supplies and capacitors. It seems to be now. Amplifier circuits. Still think this is the best one I've done so far. But yeah, I mean, yeah, it is the best one I've done so far. I'm not going to think that it is. I'm not even going to question in my head it is. That's the best one. I like it, I like it. And it does sound great, and I think once this is going, I might just put like a little sound thing up. I've been looking for some decent free music, you know, so should we have a little look and see what happens here now. So we got 2.2, hopefully it's going to decline down a bit. Good, that shows that's doing what it's supposed to do. So I've turned this, I think I've turned it quite a way down now, so well, what we don't want to see it do is just start shorting across. So we've got 0 volts there, so put that down, let's start just looking at that, and by the looks of it I'm not actually connected to anything. Let me just check these connections and see if I've done something silly wrong here. I've probably just not pushed in far enough or something. That's going in, that's connected there, that's connected there. Is that falling out of here? Could have done. That's connected there. That's for the other ground, and that ground's on there. This thing is out of the way. Let's put that just in there so I don't. Okay, let's try again. Let's try again. And start going up in voltage. Why am I not going up in voltage anywhere? Nothing's happening. It's not turned off, is it? No. What's going on? Okay, strange. Right, let me just look at that again. So we got our two connections here. This could have come out, of course. So let me just pull that out of there, pull that out of there. Just check that hasn't, because this does. This is a bit of a weird fitting. I think it came with some cheapo tester, but there you go, that's better fit. Came with some cheapo tester, but it does come in handy for doing this sort of thing. I should probably get the other leads out, not other leads. Okay, so this is just for the voltmeter. That's one side of the thingy. This is for the other side, the positive, the negative rail. That's just for the volt testing, so I can see what's going on the volts on there. Let's give it another go. Give it another go. Down with that. And up we go, but we don't seem to have any volts, and I'm not going to keep turning that up until I figure out what's going on. That's on. That's on. Hold this out, have I? No. Oh, maybe there's something dodgy there. Let me just check that connection and give it another go in a second. Okay, well, let's give it another go because I can't, no, let's just pop this up, I can't. But as long as that just makes a bit of a connection, don't matter, it's this one, and this one's the main one, and that's definitely connected to that. Definitely connected, just make sure it gets even better connection, there's nothing wrong with that. This one's always a bit dubious here. But that should be okay, so and I can keep an eye on the voltage coming out of this on here, and that's what I'm going to do this time. Just have a little wee look at that, see if it's going up, and it's not going up. It's not going up, so the variable AC is not working. Oh, there it is. So yeah, the variable AC is working. It's just, as you can see, yeah, so that's going up. Okay, we're going up there as well, 4.2. Don't know what that was all about. I was going to squeeze my hand in there. Oh, let me push that up out of the way because I need to see both of those meters. And as we're going up on the voltage, that's nice, we're at 11 volts. That's not doing a great deal. I'm going to take it up to sort of around about 40 volts and just start just twiddling that bias. So I'm on 35, that's good. I've got nothing jumping across doing anything absolutely crazy, which is nice. Let me just get the twiddly stick on here. Oh, and just start watching those meters over there. It just gently does this. I'm on 37.5 volts. And just going to give it a few more twiddles. I did give it quite a few twiddles backwards. I can't really see a great deal happening. Got 50 volts going into the transformer, 37 point, well, 50, 60, 70. Can't seem to get a great deal coming off this bias load. Is there something wrong here? Is this not connected? Maybe I need to just back that up a little bit because I seem to be twiddling quite a lot to the right. So I'm just going to back that up and just turn the power up a little bit more and just see if we get anything else on this current going up. Okay, so that's around 50 volts now. So I'm just going to back that down because I should be able to get that up. With 50 volts, definitely there shouldn't be anything. I'm giving a bit of a twiddle. Oh, okay, we got some action going on now. We got some action. So if I just put it, okay, just let that settle out a bit. We'll just keep it, just gonna back that down a bit, just twiddle, okay, so it's got nice action there. Nice response. If it's, as it's warming up, you see it's just gonna do, but nothing's doing untoward. That's nice. I'm gonna be able to count this properly now, haven't I? So 50, 60, 70, 80, 90, 200. Okay, so there's 50, 60, so 170 volts going into the transformer. 50 volts coming between these two here. And I think we have an amplifier which is doing its job again. Hey! Oh, that's good. And it's warming up nicely and it's just gently going up. I don't know if you just noticed there was a little bit of a quickie there, so I'm just going to back that down because I'm going to keep them pretty much low before I take it up to 70 volts. And I am now starting to have it between the highest one, like on the right hand side, which is what the last one was like. The highest one I'm just going to have on like 25 milliamp for the quiescent. So I've been going round just ensuring nothing's getting warm or doing anything out of the ordinary. These are fine. These are fine, there's no real temperature on them at all. So that's quite good. I think what happened was it was this transistor, or the one that was there. I think because it was the smaller heatsink, and I just pushed it, way beyond. And I'm pretty sure that another mistake. I don't mind admitting the mistakes because, well, one, I admit the mistakes and I got it on record. I get to edit the video and I get to see it again, hear myself saying the mistake. It just helps me learn for the next time. I don't mind making mistakes. And this is one of the things that I've learned about electronics, and that most of the good electronics people say you learn so much by failing, so much by mistakes. And they're right. They're right. I'm going to learn that. One, I will heat sink up properly again. I'll also make sure that I will check the quiescent current at 70 volts rather than set it up for like 60 volts and then do a test the way I was doing it earlier at 70 volts without checking what the quiescent current was doing, to make sure that was staying underneath the maximum line, which is 70 milliamps. I reckon I probably exceeded that. I'm probably lucky that the other amp survived. And maybe if I'd have carried on pushing it, that might have gone too. But this one was the one that had the heatsink that was a lot hotter because it was a smaller heatsink on it. And it wasn't really coupled with that other piece of metal. I was a bit of an idiot for doing it like that. But again, another learning point. And I won't do that again. I will not do it again. Okay, I think it's settled now because it's not actually rising anymore on the quiescent, and now I need to sort of just turn it up slightly because I need to have it above 20 milliamps. And so I just have that there. If I'm going to put the other one on 25 here, but this is only at 50 volts, so I can't now set this up and start trying to do anything at 70 volt. And I'll show you why. Because if I start turning this up to 70 volt, and you see this quiescent rise up. So I'm on 50 volt now. And as I start going up, like I'm only on 51.8, and watch how that quiescent goes up rapidly. Now we're at 60 milliamps now, getting 10 milliamp away from the threshold. I'm only on 56, and I took it to 70 volts earlier. So that is a bit of a wally. So I'm going to put that back down to 50 volt, and hopefully that will settle back down to the down to that 25, which it is. So there we go, it's been on for quite a while now, and although the voltage goes up and down a little bit, not so much there, but I do seem to have it says 248 on the meter that I've got over by my monitor. Don't know if you can zoom in down there, you can see what that says, 249 volts. Oh, we don't have that there. I'm going to read it correctly this time. So just under 240 volts. 70.8. So that's okay. I don't mind if it like goes up as long as that doesn't raise too much. Now I understand now. Look, I mean there's a little bit of difference between that one. I absolutely love these meters. I do. I'm so glad that I got them, and I fixed that I fixed the 3000 volts on it. I did make a video and I didn't think anyone would be interested. I also bought a Mark V, but it was so out of balance. I took it apart, the movement, and I fixed that as well, and then resold it. Because I just didn't want to put the Mark V up there. I would have liked the Mark V, you know, with the more modern insides and everything, but honestly, I can't have 3 of those meters. And I just couldn't find myself giving up one of these two, so because they just look so perfect up there together. Yeah, so, but I made a video about that as well. I didn't think anyone would be interested in seeing it, or I thought I'd probably get a lot of stick because I shouldn't be looking in the backs of those meters and playing around with them maybe. Okay, so we've got our indicators on, and it's not an indicator as such of this is working circuit. Okay, that'll do. Alright, that'll do, around about 50 volts. And over there, it's because I had it set up earlier for 70 volts. Quiescent current, I can adjust it up, and I'm going to just do that now. Just give it a little twiddle, and up it goes. Yep, so let me just key that really low, because I know that when I look at this I think, we're working and everything's okay. Surely I have this wrong. It is not okay. You see, if I were to now put the speaker wires on and connect to a dummy load, I would have a dead short, bang, straight across there at a low voltage. And that's not good. I need to back this down because as it warms up, it will settle into what it wants to use for quiescent current, but that's not what we're trying to do here. Now I'm going to connect up at this. I'm going to disconnect this. That is going to go down pretty much in the fashion I expect. What I need to do as well is just see if I can select out of this. I was going to say and hope for the life of me that I can get this meter to react in a more sensible fashion. Now, when I put this power back on, I don't want to see that meter go blank and start counting inside its head. I want to see the count up directly. That's better. My dummy load is the picture. I'll give you a better picture. I don't know if that's just turning itself around or if I just left it like that. If I just left it like that, I'm sorry about that. But here's the dummy load. I'm not going to put anything else on. I'm not going to put the scope on it. I'm just going to connect up to the output there. Now, if I can just put that up a bit so you can see that's this on here. If I just stick this into it, I decided I would buy another battery if necessary. Now you will probably be able to see this easier than what I will, but I want to see that voltage there just drops. Can you see that? I hope so. So I connect onto my negative. I know that those two are isolated from each other over there. Oh. And it doesn't drop. So you think that that would be okay, right? Okay. Now I'm going to show you. And I'm certainly going to back off this. Let me just turn it all the way down. Okay, do something about that. Can I do something about that? Can we see these and not have this light? I just need it so I can see the stuff a bit closer up. Oh, but this really does come in the way. Okay, so maybe if I put this like this, it might make life a little bit easier. So let's put the power down. Now I'm going to very gently start going up on the voltage because I'm only on 100 milliamps. But if you see this, that's still at 6.6 volts. But as I start going up, look at that. Look. Up it goes, and that's at 6.9 volts. The other side isn't moving at all, but that's 50 milliamps. So I'm going to back that off because I know there's a problem. That could indicate a short, but what it only does it if I have a load connected on the speakers. It only does it if I have that load connected on the speakers. So What could that be, you may think? Is it a short? Have I done something, you know, really silly? Is that all off? Yeah, I'm just going to turn it off to save that battery. I will buy some more batteries, and so I'm not going to be too tight in that department. Let's disconnect the power. Let's disconnect this, so we're isolated, and we can also disconnect these two meters as well. And I'm going to take these off. There's a nice chunky bit there. And take that off. Right, so that should be okay using this, because this is the same size, even a little bit chunkier than on the other channel, and that survived the 70 volts, 16.5 volt output RMS test. So this, which has got even more to it than this, should be fine for this channel too. Now let's see what's wrong with this. So I went over all the connections, and I know this isn't the prettiest of soldering. I know it's not as pretty as the other one, but this one's had to be taken apart a couple of times. Let me bring some light down. Okay. So yeah, like I say, it's not the prettiest. Now, I couldn't find any shorts, I couldn't find anything that was connected to something that it shouldn't be. But what I did notice was when I looked at this angle, I noticed that there was a connection here, just not quite on that one. And this is the base to what then becomes the current control. And that should go on to, if I push that down, that should connect to this resistor here, which is the output from this long tail pair. It was remarkable where I was today and do a bit of work. I got this and I was building it in my mind, because that's what I want to be able to do. I want to be able to go places that I'm supposed to do other stuff, and while I'm waiting for things to happen, especially when you're working with computers, sometimes you'll sit and wait for a while, just be able to run through circuits. Anyway, so this is it. You'd think, well, it's just the connection that's not made a very good connection. So I'm going to solder that up now, and I'm thinking that that should then be fine, and I can connect that dummy load, and that's what almost seems like it's shorting out. It won't happen. I got my fingers crossed, because I don't know. I have not soldered this up. I had to leave, and I've just left it. I've come back, I've eaten, and now I'm getting back into this. So I'm not quite sure, but I'm hoping that that's going to be what the issue is. And can you see that? It's just the lights. I don't know why I haven't soldered it as well as what I should have soldered it. I don't know how that managed to come apart, because I didn't take this out. Oh, that's a bit of a lie actually. Yes, I did. I disconnected this because I tested it within the circuit by just disconnecting the leads, because it was easy to do that one. It was easy this one and this one, but I just obviously didn't solder that back down. I pushed it over but forgot to solder it. So let's have a look. Let's get it soldered and see what that's like. I'm going to switch off while I do that, because it's means you'd have to just watch that or listen to me. Ah, look at this. You see, I was getting all in front of myself because I want to show you this. And I want to show you without knocking off my... I need to put that up on voltage actually, don't I? Without knocking off the camera. So I'm going to do some positive connections. Damn it. I really do hope it's this now, because I want to... It's Friday. I'm not going out this evening because I just don't want to. And I should have probably given it a bit of a ground connection. And I want to have a little listen to some music once this is fixed, and do the power test again at 70 volts and see if I can break it all again. I do hope those with hearing impediments can hear what I'm saying. I don't intend on changing. You will not change me. No, that's no good. Let's put it like that. I will knock it off else. Right, so that's about as close as I can get, just the way this is. So look, we've got 6.5 volts there. You can see that. Stupid light. Well, you have to just not see the circuit so much. There you go, 6.5 volts. And I'm going to connect up this dummy load. Yeah, is that all in? Looks like it's all okay. Bring the light down so I don't touch anything that I shouldn't be touching. Oh, I probably want to put some heat sinks on as well, because I'm just finding that now to be pretty good goddamn practice. So I get that and I settle that down and push it downwards so it's firmly, he says firmly, that's it, firmly on the perf board. And the other one the same thing. Just a little bit of a trying to get that in there, but as long as that gets in there, that's good. So good, two good connections there. Okay. Let's get this ground on here. Okay, insulate it down as far as I can. Not so bad for that, because it's not going to touch anything else. So there you go, and that's connected up to the dummy load. Right, let's get some power into this and see what happens this time. So power's all the way off there. We've got 6.5 volts on there. We're still on 100 milliamps, and to be honest with you, they shouldn't really go up any further than 30 the way I've got it set up. They might do a little bit because at 50 volts, because it just might be like that. But let's do this now with the dummy load on. Let's see what happens. Let's see what happens. Oh no, possibly it could go up, but it should come back down again. There you go. Did you see that? See, that's normal. That's normal. So I'm going up here. 9, 10, 10. I'm keeping a good look on the meters at the top. You get to look there. I want to get at least 40 volts or at least 20 volt per side before it's really doing anything that it's supposed to. So there we go. We're going up rather symmetrically, but I need to just turn it down a bit. Even though it's good from between 20 and 100 milliamp, I still like the idea of just keeping things low. Oh, take that out of my mouth. I can't talk with that in my mouth. And I hope you got to see that then. I hope I wasn't just like facing this camera into nothing. And I was just doing that. So I'm on 36 volts now. Let's take it up to 40 and just start backing that off again. So I'm 40 volts now. Let's start backing that off. So there we go, look. When I thought it was done, because when I first connected it like this, and to be honest with you, last night I had this thing set at 70 volts and I had it there for a good old while, at least an hour or so, while I was just watching the quiescent current and just tweaking it to bring it down, and having the left one on 25 and then the right hand side one. When this one's on 25, the right hand side one should be around about 28, 27, 28. And if you look at the way that is, I hope you can see that. Is this thing on autofocus? No, it's not. Is it on autofocus? No. Yes, it is. Sorry if anything's been not so good focusing. You see it's just gently climbing. Just like that, it's just gently climbing over 25. That's okay. We're on 45 volts, so I'm just going to turn that up a bit more. Let's just put it on 50 volts for now. Yeah, 50 volts. And I am very happy to see that this that the multimeter did not do that thing where it, because that's going to go up a little bit warm, that's going to go up a little bit, you see, as the heat, so I can just put this thing down. But I'm very happy to see. I was getting quite distressed with this, that it was going to be going up and then going blank for a couple of seconds and then coming up with a new figure, because that's just no good for me. That's just no good for me. I'd have started throwing things at it. Metaphorically speaking. I'd just show it to somebody else and let them have it. Very happy it's not doing that. So that's not going to be an issue with me at all. I just take it off the dual reading. And the dual readout, it does that. But I don't care. It's not. I don't want the dual readout. That's perfect for me. It's a bit higher resolution than the other one, as you can see. So, great stuff. And I'm still connected to that dummy load. And that shouldn't be really getting warm at all because I haven't got a signal going into it. But that's great because now I can hook up the oscilloscope and start putting in a signal. Now we can see what we can get out of this on power just by itself, on that transformer by itself, and then I'm going to do the same thing. I'm going to hook them both up. I'm going to get this tweaked up to 70 volts.